Welcome, everyone joining us. This is Brian Cardiff. He's going to talk to us about long-running tasks. And all right, if you're ready, you can take it away.
Hi, everybody. Thank you for joining me. This is going to be like a proposal. It's a work in progress of a chart I worked a little bit time ago. I had a lot of fun because partially I was motivated because I have suffered from this long running task. But so I want to go through some motivations, a small example, just to have something concrete to talk about. And then we can go into the details of the proposals and what kind of, where it can go from where it is right now, which is like a work in progress. It's not finished. But I think it's useful and valuable. So getting into the motivations a little bit. There are some tasks that usually it can be summarized as doing a certain amount of steps until it's done. Basically, while not done, you do a step and then you finish. Each time I need to code a program that matches that pattern, I feel uneasy if the do step can take like, I don't know, 10 seconds, 20 seconds. If that step it's long enough, I will be slightly pissed when I need to cut off all the progress so far and run it again. This is present in web crawlers or in ETLs on when doing batch transformation and you need to start all from scratch. It not make me happy when I need to start all that again. Is the audio okay? I see that the camera is lagging. Can I get a confirmation from
I think
there?
the audio is okay for me. The camera might be lagging a little bit, but the audio is good.
Okay, good. I will try to move slowly so it doesn't notice that much. So this is the kind of situations that make me suffer. I suffered this on my thesis work. I had a week-long experiment, and each iteration was like a couple of minutes, and I was a lot of iteration. But I could have stopped it along the way, but because of how the programs are structured, if you stop, you immediately lost all the progress so far. So for me, these are some of the things that when they are present, the long-running task property that it make me not happy. It takes away the fun of programming when you are dealing with long-running tasks. So it might be a power failure or internet failure that cuts your experiment or your run. In the middle, there might be intermittent resource availability, like API limit exceeded. And also, it's not easy to
Brian, I lost you there for a little bit. Is anyone else having trouble? Audio lost here too. Okay, let me message him real quick. I'm gonna throw myself on screen. Hello, everyone. We are just experiencing a little bit of difficulty here. So, hi. So just to bring you back into it, we heard you around API rate limits and getting kind of cut off from those and restarting tasks.
Right.
Are you able to?
Can you see can you see the screen?
Yep, and you're moving a lot more fluidly now. It looks like the internet has gotten a little bit better.
Right. It's good to have like 3 Wi-Fi's on your home. Right. Sorry about that. So internet failures can cause this kind of pains. API limits might be exceeded, and you will not get progress information if you code just a while loop. So this proposal will go through a different way of structured application. It's not that it's as straightforward as a while loop program, but we will be able to deal with these nuances a little bit better. And also, like when I need to work around API limits or see the progress or saving state for being able to re-execute later or continue the execution later, my mindset is changing between doing the task that I want, doing the computation that I want, and how to orchestrate or how to do that computation. Like those are two separate challenges, and it takes away the fun that I need to constantly switch, like what I want to do with the data and how I need to get the data. So at least for me is that I can have fun only if I deal with those problems separately. I don't want to deal with those at the same time. And also it's a way to say, hey, let's solve this program in an abstract way and have fun solving that problem, that when dealing in the context of another thing that I need to solve, it kind of bugs me. It takes away the attention. Great. So jumping a little bit on the example, it's a small example, so bear with me. We have an array of data of numbers, and we want to sum the square of those values. Everybody here is probably fluent in Crystal, so I guess this is pretty understandable. But if we want to assume that the power function is really heavy, and if I powered some of the elements of the array, I don't want to do those again in the context of the execution that I launch. Well, we need to split this in tasks. There's an overlap with background jobs, definitely, with what I'll be saying. But basically, if we go to some little drawings, if we have this task with these square sums with 1, 2, 3, 4, if we want to split it in like each task, either it is completed or it needs to be re-executed eventually when a worker starts. So the best thing this task can do is split itself in another smaller task. Like I want to do the square of each of the elements independently. And after all those 4 tasks are completed, well, there is another task that can execute and will be grabbing those results and making the sum and storing the final result. So more or less, we are splitting this in a bunch of different tasks. I mentioned already, this is similar to what happened on background jobs. There are some limitations, like arguments will need to be serializable. We'll be assuming that there is a single argument. If you have many, you just box it on a struct and you can work from there. But also, I just mentioned the result of the square element function, that those will be grabbed by the some result task. But each task usually don't have a result as a function. They have like side effects, like sending an email or storing some information somewhere. And basically, that's what we are going to do. Like each of the square element will be able to have access to some shared store, persistent store that can be reused eventually by any other worker if this worker that is running this task crashed. So there will be these circles are single values stores or boxes in a key value store, for example. So each square element task will be able to write information there, and the final task, the sum result, it will know the dependencies task. So from there, it will be able to grab the output or the output stored in that key value. So this is more or less the example I will use to go through some of the APIs. And then how we are going on time. Good. So if we want to jump a little bit on code, if images were not enough, this is more or less what we got today. I need to set up an application. The library is called Tasko. It's a task in Esperanto. All the names were already taken. So I will initiate a task, which is kind of the runner or the worker. The engine will be probably the store that is keeping the registry of the task to be executed, usually Redis, but it could be memory at some degree. And then you define the task somehow. We'll get on that later. But from the user perspective, you can schedule tasks and run. When all the tasks are done, well, you will be able to somehow extract the result. Again, the task does not have an output as function, but they have side effects. So we will be reading that from the store, from a key value store. So, and since we will be using Redis all the way down, there are some convenience classes. So I will be able to create a key value store with some type definitions that I will be used to define the task, but also I will be able to get this value that will be written by the last of the tasks. So these are more or less the pieces. We have the application that will have the task defined. We have the engine that is already written and provided and will give us some guarantees, and some helper for key value stores. It's nice that the key value store will use the engine of the application. So if we switch engine, we can switch from Redis to memory. So we can run specs faster, and we can decide what backend engine to use. So if we go to how tasks can be defined, spoiler, it might not look that tricky. I will come back later on that topic. But basically, we define procs. We give a proc a name, in this case, square sum. We're defining the task square sum. It receives a single argument that needs to be serializable, and we will receive a context of the execution. So nothing fancy. And this first task, what will be doing, it will be creating the last one, some results with no argument. And for each of the elements, we are creating another task, and we are saying that this LM task is required for the final one, for the result. So there we build the graph that I showed before. This is basically like mapping this task to each element and kind of allowing a reduced step with the final one with after all of these got executed. We also need to define the two other tasks. That will be square LM. Here appears the power function. And we see that we can take the input and we use the store to keep this intermediate result for this task. So in the context, we see there is a current task key. So it's the unique identifier of that invocation. So each task will have its slot there, and we will be able to store this task. And finally, the one that reduced the output, it can, again, from the context, it get the information of the dependencies, and for a convention between these two procs, it will be reading the intermediate result of each of the dependencies, and we'll be able to store the final result in another key, basically. So it's definitely more than the simple loop that I showed at the beginning. But with this structure, we can take a lot of improvements already. If the workers crash, we can start them again, and there will be already definitions of tasks there to be executed, so we can resume from there. So that is almost for free. We can see a lot of other information. We can see progress information, timing, if we measure it, like all those kind of things can be built with this abstraction. Another bit I was missing is the store. This is some convenient function. This is the API that I got so far. It's basically a way to define single values or lists or others in a time way, and we get this set and get for each of the keys. So, but up to here, everything is nice. But when things start to get bigger, I start to feel uneasy of what are the guarantees of the runtime of this architecture if implemented like directly or natively. Something that could happen, not in this program because there was no possible exception, but for example, when square sum is executing, if we are iterating and creating tasks, there could be an exception in between. It could be like, I don't know, a parser error of a JSON file, or I don't know, whatever exception could happen in runtime. And if we create the tasks directly when they are requested, as when you do on background jobs, you will end with a partial graph of tasks to execute. And that means that you cannot trust 100% the result, because you don't know if you are computing the expected result or not. So in order to try to solve this problem, something that has been done, I pair with this design with WAG. So the idea was to make atomic graph changes with the execution of the task. So the code is, as you saw it before, it is like that. But when you create tasks through this context.createTask method, the task will not be created yet. You will be performing, like recording a chain set. And if the task completely executes successfully with no exception, you will atomically record that task was successfully executed, and also the changes of the graph. So if either all or nothing. So with that guarantee, you are good to go, and you can trust the result. Basically, that's the good part. So I don't know. This is I think this is the most important part. Like this idea make everything work. You can throw away the source code, keep this idea, implement it however you want. It's perfect. It will be great. So basically, the task code library, it has a certain rules. I went through the most important one. These are like predecessor tasks. You can execute if all your predecessors are already successfully executed. You can only spawn new tasks if you successfully executed again. So all those kind of things are the rules of the game. And you can crash and you can be executed again. So you should aim for tasks to be idempotent if you can, similar as on background jobs. Again, the difference is when you are able to schedule new things, or in which conditions. So again, summarizing the API, right now we are using a fixed serialization technique for the arguments, and we can use Redis, or we can use memory at some degree. And so we define tasks, we can schedule tasks from the outside, and within the task, we get the access to the unique identifier, we can access to the dependencies, we can actually do something, and we can spawn new tasks and change the dependency of graph. And with this pattern is great. We can already, as I said, there are a lot of toolings that can be done, and we can even share the load on multiple workers if they all have the definitions of the task. And if you don't have the definition of the task, you can still do a lot of things. Those are the tools, like you can inspect timing or progress, and for those you don't need the actual definition of the task. You just need to know that there is a task, and you can even see the arguments because all are serializable. So as I said, Redis is the engine I use. I use the transaction Redis to give this this guarantee. The memory doesn't have that guarantee because it's not there is no transactional memory here, but it's good for testing the good path, so the test will go faster. I already covered this, and yes, and there's a limitation: single argument, explicit argument context in the. So it's not that fancy, the API. I give that, but it's what it is right now. It's work in progress, and the tooling. I think basically I mentioned all this already. Like we can build tool, and you can start thinking about tooling despite the problem. So that's great. We can divide the things. Great. So before, I will go quickly on some of the. We're almost finished, and I will cover the question that I see so far. There are two. Great. So and this can be extended like this. There are ideas like how many times we can execute a task if it was failing before declaring it that it's a total failure, or we can define we can declare resource management. So maybe some workers has access to some resources, so the task should be handled by them. So there are a lot of things that can be orchestrated, and that will not get into the weeds of the program itself. And to address the API thing, it will be definitely nicer to have a more type-safe dispatch. But some properties of this context make me feel uneasy. Like, what was the correct solution? So actually, I'm not sure. Like, I would like to don't be needed to pack all the arguments in a single one and use like the bottom part. But when I invoke a task, I don't need to have a context. But when I define the task, I need to have access to the context. And also, as we saw, it's convenient to have a store. But in the pro version, the store is closure, so it's really simple to get access to that. But if I use def, since there are no globals, it's not as straightforward how to get access to there. So, and we could define some specific patterns, or like if you inherit some class, you will have access to the store that is typed in a generic argument. But it was like forcing too much. So basically, I don't know. I didn't want it to force it too much, and like this method, the Quox method and the Quox method here, they are unrelated. Like I would like to be able to find reference from this method and find the source here. So and unless we get that guarantee, it's like halfway implementation. And also like Crystal is a complex language, so we have default values for arguments, yielding methods. There might be arguments that are not serializable. So I want, if we are going to use defs to define tasks, I want like to have compile time guarantees that we are not messing things up, so we don't discover things later. So basically, in this case, getting a simple API, it means not having a fancy API. But I don't know, for this work in progress, I think it's fine. The repository is here. It's called taskos.cr. And basically, that's it. Thank you.
So I think there's a few questions that kind of revolve around comparing this to other libraries or other implementations of some things that are similar. So how does Tasco compare to something like Sidekick or Active Job? Do you have any comments on that?
Yes, there are both of those are background jobs, and the idea there are a lot of overlap. The idea of that jobs can be re-executed, and you should be prepared for that. So I don't know, if your background job sends an email, you will potentially send many emails. So that changes you how you approach the program. That will be the same for here. The main difference in the runtime is that when on active job, or with like when you dot perform later or deliver later, that is actually scheduling a job. But here on Tasco, that will not. That only if the task itself success, you will schedule a new task, and you have this graph. I think those are the cornerstone for being able to compute things in a task-oriented and not just scheduling for later execution until it's success.
Okay. Very awesome. I think this one from Ryan is a great one to end on. We have to bring Kirk up in a little bit. Could we, in theory, use Postgres as an engine to be able to stop jobs in the same transaction as other DB stuff? I'm guessing there aren't APIs for this yet, but I'm just curious. Does that make sense as a question?
Yes, it makes sense. There is no engine on the DB, but it's definitely doable. There is enough guarantees there to perform the graph modifications with the task completion. Mm-hmm. I will say yes. It's more a matter of how we share the transaction, the nested transaction between whatever code you want to write and the task execution. But at the end of the day, you always have other side effects like sending emails, sending requests. So yes, you can, but also it will be probably incomplete unless you only deal with that database as an outside system, I would say.
Awesome. Well, thank you so much. I'm sure everyone will thank you in the chat as well. And if you'd like to, you can probably start with the attendees Discord channel and maybe go into the chat channel and talk with more people about this. I'm sure that there is a lot of interest in long-running background chat tasks. But thank you so much, Brian, for your talk.
Thank you. Thank you, everybody. See you later.
Okay.